Hello friends, in this lecture we are going to discuss the important topic transistor BJT, bipolar junction transistor. This bipolar junction transistor is actually combination of two PN junctions. As we have discussed PN junction diode, which is a combination of P junction and P type semiconductor and N type semiconductor. So one of the disadvantage of that PN junction was it can't amplify the signals. It only switch the signals, means we can switch the signal using PN junction, but it is not possible to amplify the signal. So to do the amplification of the signal, we required BJT. This BJT, that is bipolar junction transistor, was invented in the year 1947 by three scientists, Barden, Brittain and Shockley. Now this BJT is a basically two junction, three terminal and three layer device. So this is a two junction, three terminal, three layer device. Why two junction? Because in case of BJT, if you observe, suppose this is a PN, again N and again here suppose P. So it consists of two PN junctions, and this N side or N region is placed or sandwich between two P type semiconductors. So whenever this N type semiconductor is sandwiched between two P type semiconductors, then it is called as PNP transistor. And suppose if this is a structure and this is N, this is P, this is again P, and if this is N, then this is NPN transistor, in which P type semiconductor is sandwiched between two N type semiconductors. It means there is a combination of two junctions. That's why this is called a two junction device. Again, it is a three terminal device. Three terminal device. Before discussing the terminals, first we look into the layers. So this BJT consists of three layers. What are the names of three layers? Emitter region, base region, collector region. These are the three layers of BJT. Okay. Now, in case of this BJT, B for bipolar, J for junction and T for transistor. The bipolar, bi means two. So in case of this BJT, both type of charge carriers are available for conduction. What are the names of the charge carriers? Electrons and holes. So it is not the unipolar device, it is bipolar device, because the conduction take place due to both the types of charge carrier. Okay. Now actually if you observe the structure, this BJT is back to back PN junction diode, obviously because it consists of two PN junctions. So this is the first PN junction, this is the second PN junction. So this is one diode, this is one diode, but back to back means in this case this is a cathode of first PN junction, this is a cathode of second PN junction. So these two cathodes are tied to each other. That's why this is back to back PN junction diode. In this case, this is NP, PN. So this is an anode of first PN junction. This is an anode of first PN junction. This is an anode of second PN junction. So these two anodes are tied. So that's why this is back to back PN junction diodes. Another important point, this BJT is a current control device. It is not voltage control device. It means if it is a current control device, it means there is some terminal which is required to control the current. That terminal is control terminal. So in BJT, your input is current and output is current. It means when you change the input current, your output current also change. That's why it is called as current controlled device. Okay. Next important point, types of BJT. What are the types of BJT available? Basically there are two types of BJTs are available. First one is NPN BJT or NPN bipolar junction transistor. that is this NPN. Second is PNP, bipolar junction transistor. Now, if we want to study the symbols of the transistor, so this is a symbol of NPN transistor. If you observe in this symbol, basically you are observing three terminals: base, emitter, collector. Okay, base, emitter, collector. These are the three terminals. Why three terminals? Because there are three layers, and to each layer there is a one terminal is connected, and that terminal is called as emitter, base, collector. That's why it is a three terminals device. Okay, next, this is also NPN transistor, this is also NPN transistor, but it is drawn in some different manner as compared to this. Working of both same. One more important point, if you observe the direction of current flow in NPN transistor, current flow from this base to emitter. That's why this arrow is outward. This arrow is outward. It means the current is flowing from base to emitter. Okay. Now this is PNP symbol of PNP transistor. In PNP transistor, if you observe, this is emitter, base, collector. This is also collector, base, emitter. Technique of drawing the symbols is different, but both are same. In this diagram, A is the symbol of PNP transistor and B figure is the construction of PNP transistor. In the same manner, C is the symbol of NPN transistor and D is the construction of NPN transistor. Now one important difference between this NPN and PNP in terms of symbol, the current in PNP transistor is coming towards the base from the emitter. So the arrow is towards the base. In this case also arrow is towards the base. So important is what? If you want to identify the type of transistor and you have been given two symbol, identify type of transistor, then by looking into this arrow, toward this arrow, you can identify easily. If arrow is outward, it means it's from base to emitter, it is NPN. If arrow is inward, it means it is from emitter to base, it is PNP. Clear? Okay. Now we are going toward the structure of BJT. Basically what it consists of? It consists of NPN, it means basically two PN junctions. This is the first PN junction, this is the second PN junction. These two PN junctions are joined together to form a BJT. It means whenever P-type semiconductor is sandwiched between two N-type semiconductor, then it forms NPN transistor. Okay, then this NPN means N-type semiconductor is formed by adding the pentavalent impurities into the pure semiconductor like silicon, and this P-type semiconductor is formed by adding the trivalent impurities into the pure semiconductor. Okay. Now this PNP transistor is formed by sandwiching the N-type semiconductor between two P-type semiconductor. So this is an important point. Clear? So this is a structure of NPN and PNP. Now another important point. If you consider N region, P region, again N region, this region is called as emitter region. This region is called as base region. So terminal is base. This region is called as collector region. So terminal is collector. For a PNP also, this is emitter, base, collector. Now, if you observe this diagram, you are observing the area of this collector region is more, the area of base region is very, very small, or it is very, very thin, and the area of emitter is moderate, intermediate between collector and base. Now, again, area of, in PNP also, area of emitter is moderate level, moderate, area of base is small, and area of collector is large. Okay. So in terms of area, you are observing the some observations like area is more in collector rather than base. Okay. Now this is a two diode analogy of BJTs. This is two diode analogy means what? This is a one diode, this is another diode. when these two diodes are joined together or connected together in such a manner that the cathodes of two diodes are connected at a common point, then it forms a transistor. Why? Because it is actually what? NPN. Na? NP means one PN junction, means one diode, again second diode, but they are joined in such a manner, N should be common. Na? It means what? Two cathodes are connected. So it is two diode analogy. That's why it is called as back to back two PN junction diodes. Okay. Yes. This is a symbol. This is a symbol for a PNP transistor in terms of two diode analogy. So these two diodes are connected in such a manner that the anodes of both diodes are connected to each other. So these are the anodes of two diodes. Anodes, these are the cathodes, these are the anodes of two diodes are connected to each other. It forms PNP transistor. That's why BJT is equivalent to the connection of two diodes back to back. Okay, so one BJT is equal to two diodes. Clear? Yes. Now this is a table which indicates the comparison of three regions of BJT in terms of doping and area. It means what? If emitter region of transistor is considered, then it is heavily doped. Okay. Then area of the emitter is moderate, that I already discussed. Now base region of the transistors is lightly doped and its area is what? Small. That's why base is thin. And the collector region is moderately doped, means in terms of doping it is between emitter, in terms of doping it is between emitter and base, and area of collector is very, very large. Okay, so in this manner you remember the doping and area of each region of this BJT, which is shown in on the board in terms of diagram as well as in terms of tabular format. Now terminals of BJT. What is the function of each terminal? That we have to discuss. Emitter. Emitter means it emits. What it emits? It emits the large number of carriers for the flow of current. That's why this is called as emitter. It emits the carrier. And the terminal attached to that emitter region is emitter terminal. Okay? Yes. Next is base. Base is a control terminal that I already discussed. Is control the output current. Okay, so controlling is the important function of base region. Okay, then next is collector terminal. What is collector function? As name itself suggests, it collects collector. It collects the charge carriers emitted by emitter. This is the one important function of collector. Second important function, it dissipates any small amount of heat generated during the process or during the working of transistor. Anything heat is generated, that heat should be dissipated to protect the transistor, and it is done by collector, because that's why the area of collector is large. Okay, so that its thermal resistance increases. Okay, so these are the three functions: emitter supplying the carrier, base control for controlling function, collector collecting the emitted carrier and to dissipate any small amount of heat. Now some another terms involved in this BJT, that is depletion region. Why this term is present here? Because in transistor is a two junction device. Junction means, okay, junction means what? Actually in transistor the junction which is present is what? It is not homogeneous junction, it is heterogeneous junction. Why heterogeneous junction? Because it is present between two different semiconductors, that is P type and N type. So basically in case of this transistor there are two junctions are present, P type and N type. Doping is also different because base is lightly doped and emitter is heavily doped. It means what happens? There is a creation of depletion region. Why depletion region? Because as the base of the transistor is lightly doped, so and the emitter is heavily doped, so what happens? The large number of carriers from the emitter diffuse into the base, and due to which what happens? There is a creation of what? There is a creation of depletion region. There is a creation of depletion region in the at the junction of the transistor, and this is called as depletion region. That's why it forms at emitter to base junction and collector to base junction. So one important another point, what? In transistor there are two junctions and names are emitter to base and collector to base. These are the names of the junction. Next important, currents in case of transistor. As the three terminals are present in the transistor, the current components are also three. The current flowing through the emitter terminal is called as emitter current. Then the current flowing through the base of the transistor is base current, and the current flowing through the collector terminal of the transistor is collector current. So three terminals, three current: emitter current, base current, collector current. Okay, so in transistor, three regions: emitter, base, collector. Terminals: emitter, base, collector. And names of the currents are emitter current, base current, collector current. Okay, now one important point. In transistor, two junctions are present. What are the names of junction? Emitter to base and collector to base. Emitter to base, collector to base. These are the two junctions. Okay. And for normal operation of transistors, one important point is emitter to base junction is FB and collector to base junction is RB. It means emitter to base junction is forward bias and collector to base junction is reverse bias. It means emitter to base junction is forward bias, means emitter is more positive than base and collector is more positive than base. That's why collector to base junction reverse, emitter to base junction forward bias. Okay, so this is the introduction about the transistor in terms of its connection and symbols. Now we are going to discuss working of NPN transistor. Actually this is also called as transistor action. It means how the carrier flow is maintained into the transistor. Now listen here, consider this is an NPN transistor in which three regions are, that is emitter, base, collector, and terminals are emitter, base, collector. Now we discuss the emitter to base junction is FB, forward bias, and collector to base junction is reverse bias. Okay, now actually emitter to base junction is forward bias. It means what? We have to apply the voltage between the emitter and base. Now second important point is the polarity of the battery is also important here, because as this transistor is NPN, so to make the emitter to base junction should be forward bias, we have to connect negative terminal of the battery to the N side and the positive terminal of the battery is connected to this P side. That's why this particular PN junction is now forward bias. Now, so that the voltage across this emitter to base is VEB, that is 0.7 volt. Okay, why? Because it is a silicon material. Similarly, the collector to base junction is reverse bias. Now to make the collector to base junction reverse bias, you have to connect this another battery which is VCB in such a manner that this particular terminal of the battery, that is positive terminal of the battery, should be connected to N side and negative terminal of the battery should be connected to P side, so that this CB junction is RB and this BE junction is FB, that is forward bias. So this is an important called as biasing technique. It means connecting the battery with proper polarities between the junctions of transistor is called as transistor biasing. Okay, now how it works, that we have to discuss. Consider the applied voltage between base to emitter is less than 0.7 volt. That time what will happen? As this is a N-type semiconductor, so majority charge carriers are electrons. So definitely electrons are present here. But Since the voltage applied between emitter and base is less than 0.7 volt, so what happens? These electrons will not enter into this base region before the 0.7 volt. So no current flows. Now once this VBE, that is case number 2, that VBE is greater than 0.7 volt, so this particular emitter to base junction is now forward bias. Definitely if this emitter to base junction is forward bias, so definitely the electrons crosses this particular junction and enters into the base region. Okay, so when this electron enters into the base region, so what happens? There is a process called as recombination. Electrons enter into the base region by the process of diffusion, and after entering the entry of electron into the base, they faces the process recombination. It means what happens? That electron recombines with this base and it constitute a current called as base current. Okay, and when these electrons enters into this base, that time it constitutes a current called as emitter current. So actually this emitter region is responsible for the emitter current, and this region is base region is responsible for the base current. Okay, now whenever this recombination occurs inside the base, so these particular electrons which are in the n side enters into the base region, and after the recombination of the electron inside the base, remaining electron, okay, that remaining electron experiences heavy electric field when they enters toward the collector to base junction, and due to that heavy electric field, these electrons are attracted. Why? Because the polarity of the battery is positive. So these electrons are attracted by this particular supply. That's why this region is called as collector region, because it collects the electrons from the which are emitted by the emitter. So these can be explained with the water tap analogy, in which that tap acts as a control, which is a base, okay, and you are collecting the water. Okay, so this is an important non-technical example of this working of transistor. So while writing in the paper, you have to write in this manner: current through the emitter to base junction is very large when emitter to base junction is forward bias. Okay, now when base to emitter junction is less than barrier potential, it means 0.7 volt, that time no electron enters into the base region. Second, next point, when emitter to base junction is greater than 0.7 volt for silicon, that time electron enters into the base region, they constitute current called as emitter current. Afterwards, when electron enters into the base region, they recombine with the electrons in the base region and constitutes the current called as base current. So this is the base current, and the remaining electrons inside the base enters into the collector, and due to the electric field, and constitutes current called as collector current. So these three components of current are justified with the help of this diagram, that is emitter current, base current and collector current. Now some important statistical data that we have to understand. Suppose 100 electrons are emitted by the emitter. Okay, these 100 electrons enter into the base. As the base is thin, what happens? Out of 100, 2 electrons recombine with the holes inside the base. So how many electrons are now remaining? 98 electrons enters into the collector, and these 98 electrons are collected by the collector. That's why the area of the collector is large. Okay, and it constitutes a collector current. So this is a working of transistor. Now one important point, why the name transistor? Transistor means transfer of current from low resistance region to high resistance region. Why it is called as low? Because as you know that this emitter is heavily doped. As its doping is low, you know that the depletion region that we have discussed, that depletion region penetrates more in lightly doped side. As this emitter is heavily doped, so depletion region width inside the emitter region is very less. So resistance offered by this emitter is very, very low. Why? Because depletion region acts as a barrier. So that's why this region is of low resistance and our current is passing from emitter to collector. So that's why the passing of current or transfer of current from low resistance region to high resistance region. Why high resistance region? Because this base is lightly doped, and due to the doping of base is very, very less, the depletion region penetrates more inside the base. So it offers more resistance, and that's why there is a transfer of signal from low resistance regions to high resistance region. That's why the name is called as transistor. Okay, that is transfer plus resistor. Okay, so in this manner transistor works. And finally, this important equation you have to remember: the emitter current is equal to base current plus collector current. IE is equal to IB plus IC. 100 electrons are emitted, 2 recombine forms base current, remaining 98 forms collector current. So total 100 is equal to 2 plus 98. IE is equal to IB plus IC. So at this node, if you observe, incoming current is equal to outgoing current. Incoming current is emitter current. Outgoing current is equal to IB plus IC. So that's why incoming current is equal to outgoing current. The summation of outgoing current is equal to incoming current. This is the current. This is called as the transistor current equation. IE is equal to IB plus IC. Okay. So this is the transistor action. Now we are discussing transistor configuration. Now what is the need of configuration of transistor? As suppose I am considering, suppose this is a network and that network consists of 4 terminals. This is a network, black box, 2 input terminals, 2 output terminals. Now in our transistor basically there are 3 terminals. So if we want to use our transistor as a 2-port network, 2-port network means input port, output port. It has 2 ports and each port has 2 terminals. So total 2 ports. So total terminals are now 4, but our transistor has how many terminals? 3. So it is necessary to utilize any one terminal of the transistor for both. It is also used for input port, it is also used for output port. Now how many terminals are there for transistor? 3. Emitter, base, collector. So when emitter terminal of transistor is used for input port as well as for output port, that time that terminal is called as what? Common terminal. Which terminal is common? Emitter terminal. That's why this configuration is called as what? Common emitter configuration. Clear why it is called as common emitter configuration? Now, as the transistor types are 2, that is NP and PNP. So how to draw the configuration? Listen here. This is an example of common emitter configuration. For NPN, this is base, this is emitter, collector. Current flows from base to emitter. That's why arrow is outwards, as I already discussed. Now this emitter is common. It is also for input, it is also for output. It means it should not affect the electrical connections or current components. That's why we are taking this emitter as 0 potential, ground potential. So it is common. So emitter is common. Okay. So now rest 2 terminals are base and collector. So these 2 terminals are now act as what? Input current for base and output current from collector. So in common emitter configuration, input current is IB, that is base current, and output current is collector current. Then in common emitter configuration, input voltage is between base to emitter and output voltage is between collector and base, emitter, because emitter is common. Clear? So this is common emitter configuration. Now suppose we are making now base of the transistor is common. In that case it is common base configuration. As the base is common, so major task is what? We have to identify the input current and output current. Base is common, so eliminate the base. So remaining terminals are emitter and collector. out of which collector cannot be the input current because it collects the electrons. So that which terminal is left? Emitter. So that emitter current is the input current for common base and collector current is the output current. And voltage, input voltage is between emitter and base. So it is VEB, and output voltage between base and collector. Now another important question. Input voltage between emitter and base for common base configuration is VEB or VBE? It is actually VEB because base is at zero potential. So potential difference, higher potential minus lower potential. That's why it is VEB means VE minus VB, and VBE means VB minus VE. Okay. Here also it is not VBC, it is VCB. That's why it is VC minus VB. This is for NPN. If you want to draw the common base for PNP, same diagram, but arrow should be correct. Arrow should be from emitter to base. And for NPN, arrow should be from base to emitter. In this manner, you can draw the common base configuration. Now next important is common collector configuration, in which terminal is common? Collector. If collector is common, so rest terminals are emitter and base, out of which input current should be from base or collector, base or emitter, definitely it will be from base. So for common collector also input current is base current. Output current is what? It is from emitter. Why? Because collector is common. So we cannot utilize now collector for taking output. So we have to take output from now between emitter and collector. And in case in input we have to apply between base and collector. So collector is common. So for common collector, input voltage between VBC and output voltage VEC. In both the voltages C is common. So that's why it is called as common collector configuration. So in this manner we can study the configurations of transistor, because whenever we draw the configuration we have to identify input current and output current, and we have to take the output from the terminals. So these are the transistor configurations. So in this lecture we discuss bipolar junction transistor, its symbols, construction, transistor action and transistor configuration, and how to identify the input and output current components for various configurations. Thank you.